Hello and welcome to the Raspberry Pi coding channel. This is video 10. We're now in double figures of humans versus AI. In the last video, we introduced a few methods that took us down the road of introducing AI into this project, which is the whole point of the project, so that's quite exciting. In this video, we're going to extend on that by allowing a machine, in principle, to control the players, and to begin introducing a PPO, that's proximal policy optimization. It's a type of reinforcement learning, a PPO wrapper around the game, so that we can train using the game methods for training, and so that we can eventually use the machine learning model that we train for making decisions for the players. So without any further ado then, of course I have a Patreon account. If you'd like to contribute, that would be lovely, no expectation. But if you do, as a thank you, you will have access to the code directly there. Right, I'm trying to keep this video to a reasonable time, so I'm going to get straight over to my IDE. Right, so what's changing? Well, the first thing that's going to change is an import of NumPy, because we're going to need a little bit more array control, and because machine learning tends to use NumPy for the array constructs that goes into the machine. So NumPy is going to be required, so we may as well import it. So the first thing we're doing today is importing NumPy. So if we go through to our terminal, we need to install it. Now I use pipenv for my package manager in this project. There are better package managers, many of them in Python. A good one you might wish to try is UV, based on Rust, for example, but I'm using pipenv. So if I was now, as I am, in my environment, which is isolated from my global environment, so this is video. So as I'm in there, I would do pipenv install, if I can type, install NumPy. I've already done it, so I don't need to, but that's what I would do. And then I would do cat pip file to check it's installed. And you can see there, NumPy is installed. I don't pin my dependencies in this project, because dependencies very quickly become out of date. And for the sake of a video, they would be out of date very quickly, and I don't wish people to copy those, so I'm using the asterisks. But it isn't good form. You should pin your dependencies. Okay, with that done then, the NumPy import will work, although it will work anyway because Arcade has it, but we should install it, and that's what we've done. Another thing to note, another change, as we go from top to bottom from the last video, is we've imported this thing called PPO. This is not a library we're importing or a module. This is my own PPO class, which exists in my new PPO file. We're going to go to PPO file at the end of this video, talk about what that is. But basically that's what's going to wrap the game so that we can use it for training. So it'll become like a playground for training. And it's also, actually, no, that's basically what it's for. Okay, so that's that. And we'll talk about that in a minute. Right, okay, onwards and upwards. We're going to go right down to the onUpdate method, which is one of the arcade methods that I'm sure you know by now we're tapping into. And the first change is within the player loop, where we're updating the state. We are, by moving the player, we are going to add a conditional statement which says, if we're not in train mode, which I'll talk about in a second, then I want you to run the code which allows us to handle the keyboard. And if you remember, by handling the keyboard, what that means is it'll listen to the keyboard press, and it'll update the player's target X and target Y position, which is what moves the player. But now, if train is true, it won't do that. And that's because we don't want any interaction of the game engine, this game, with the player's position and the player's state if we're training. That's because we want the PPO file to take over, because we need complete control. We need to be able to randomize the player's position, get an action out of the model, reward it. So we need control. So this is why we do this. So if we go into constants then, we need to add a constant here. So you can see we're using train. So if I go into constants, you'll find that, scroll up, we've got 2 additional constants. So that's another thing that's changed. We've got train, which is a Boolean, which we've just used, true or false. True means we're in training mode, false means we're not, and you can see I currently have it set to false. And then we have model path, because when we train a model, we're going to need to give it a name. It's going to be saved as a zip file. My name is energy collection model. So there are two additional constants that I've put in here. Right, so back to this. So hopefully that's clear that we're using the same code when we're training effectively, but we need to stop the onUpdate from making any changes to the player positions because we need to control that within the PPO file. That'll all make sense when we get to it. The next thing that's happened is there was no else statement. All of this is new. Okay, so before, as you know, we could handle the player's keyboard entry, which would move the green dot around the screen. What we were missing is any means by which a machine could control the player. Well, here we have it. So what we're saying now is else, which means it's not the human player, which is defined by the if statement further above. If it's not a human player and that non-human player is not in transit, because we only want the machine to make a decision when that decision can be applied, and that decision can only be applied when the player is not moving, i.e. they've settled in a grid cell. So when the player is not in transit, okay, now we need to allow the machine to make a decision and to update the player's target X and target Y position instead of using handle keyboard. So that's what all of this is. Now, this bit's quite interesting. So in the last video, and I won't labor this because I know I go over things a bit, in the last video we covered get game state and flatten game state. Get game state creates a dictionary of game state, which is the observation for the machine learning model. It gives it its kind of eyes into the world. The flatten game state flattens that into a format appropriate for the machine learning model when we come to enter it. And if you recall, the get game state outputs the dictionary, the state, and the flatten game state takes that as an attribute, as an input or an argument. So which is why they're nested. Flatten game state takes the output from the get game state method. Okay, which takes the player as an input to make it unique to that player. Okay, a lot going on there, but hopefully that makes sense. So the other thing that's happening is it's wrapped inside this numpy method mp.array to create a numpy array from the output. So state becomes a numpy array of type float32, which is defined by the d type at the end. That's important because that's what stable baseline's PPO model is going to need as an input. So I'm just letting you know we need to wrap it in that so that it becomes a numpy array. Now we can't do anything with this yet because we don't have a machine learning model. We need to train a machine learning model, of course. So nothing can actually be done with this state, but it's good that we're now capturing it when this is not a human player. So that's a big step in the right direction. When we're not training and when it's not a human player, we are now capturing the game state, which is required for the machine learning. And if we had a model, we'd be able to use it, but we don't. So the next thing then would be, okay, let's assume the model has run and we've got an action out of it. And if you remember, the action is a value between 0 and 3. Okay, fair enough. What we would then do is this commented out line here that I've put in. What we then would do would use the other method that we created in the last video, which is the set target position ML set target position, which is the machine learning version of set target position. If you remember, the main reason this here is because it has to normalize the position and it has to make sure it doesn't go outside of the grid. So if you remember in the last video, it takes the player as the argument, so it knows the position of the player now and can update the target X and target Y position. And it also takes the action as an argument as well. Now we don't have an action yet because we don't have a machine learning model to create one, but we can pretend. And that's why I've created the equivalent line, an absolute duplicate, right above it, and I've just given it a number 3. So if we go to constants and remind ourselves what 3 means, so we've got this translation, which if you remember is what is used in the machine learning method just mentioned, the one here, the set target position method. That uses this to translate the output from the machine learning model, which will be 0, 1, 2, or 3, into a position delta. So which way are you going? A unit matrix, basically. 3 corresponds to 1 in the X direction and 0 in the Y direction, which is to move right. So that's what 3 is. So what that means then, by putting this line in, set target position, and using the method that we created in the last video, which is down here, what should happen then is we should get 1 in the x, I think it was 1 in the x, wasn't it? 1 in the x and 0 in the y. So we should get dx as 1, dy as 0. So new x should be going 1 grid cell to the right constantly, because that's the only action we're doing with each frame when the player's not moving. Okay, so hopefully you remember all of that. So let's give it a go. I mean, why not? We've put in this fake action, and it'll be the first time, hopefully, where we can move the players without the human being. There we go. The players are moving, all in the same direction, of course, but the principle is there. We're able to introduce interactivity. The game won't end because a player has to collect 5 energy points, but there you go. So we've now got the input working. So you can see that all we now need, of course, is a working machine learning model to feed in that direction, and we'll comment that out. So now that we've seen it working, I'll delete that. We don't need that anymore. I can't comment that back in because we don't have an action, so I'll leave that like that. Right, and the last thing to talk about before we wrap up today is ppo.py. This is a placeholder, and I just wanted to let you know it's coming. So in the next video, this is where we're going to be spending all of our time, is building out this wrapper so that we can train a machine learning model. And this is where it gets quite interesting. So we've got some imports that we're going to need: OS, time, and math. OS is so that we can write the model to the file. Time is so that we can put delays in where we need to. And math is so that we can use things like the square root function, which we're going to need to calculate Euclidean distance. And we're creating a class called PPO. There's lots of missing imports here. We're going to need to import stable baselines 3, gym, which is what gives us access to the model and the environment for training it, which we'll do in the next video. But the point is, we are now creating the PPO class, which will wrap the game and allow us to train it. And the thing I want to say before I end today is, in the constructor of the PPO class is gameApp. gameApp is basically the, if we go back to main, and we go down to the start where we initialize everything, this is gameApp. It's an instance of the gameApp class. And it's quite interesting, isn't it, that our PPO file is taking that as an argument. We're going to need that in the constructor. And the reason is, of course, because the PPO file, class in this case, is wrapping the game environment. It's going to need access to the game environment's methods in order to basically simulate the game and train it. So gameApp, of course, being this class all the way up here. We need access to the methods in order to simulate the game. So I hope that's clear. I hope that makes sense, and I hope that was useful. The next video, we're going to continue to build this out, and we're getting to the really interesting stuff now. Thanks for attending me on this journey and for sticking with it, and I will see you in the next video. Thanks, everybody.